Hey guys, we are going over Unit 7.1, and we are going to talk about simplifying radicals in similarity, which we learned last semester, and we're going to apply that to geometric mean. We're going to start with this, the square root of 147, and you need to find the largest perfect square that goes into 147, and for this it is 49. So if you take 147 and divide it by 149, you get 3. So these two are factors of 147. And then you take the square root of 49 and you get 7. So 7 root 3 would be your final answer. Alright, and so we have square root of 5 over 2 root 2 for this one. This one has a square root on the bottom. So remember, you need to multiply by that square root in the numerator and the denominator. And when we multiply across, it will eventually get rid of that square root. So it's going to look like this. 5 times 2 is 10. So square root of 10, that square root does not go anywhere. And then this 2 actually gets moved over here. It doesn't get touched at all. And then root 2 times root 2 becomes 2. And then these get multiplied together to become 4. All right. Moving right along to number 3. For number 3, we've got the square root of 15 times, and these are in parentheses, root 5 plus root 3. And if you look at it, you're like, well, it looks like you're distributing. It just looks weird because we have perfect squares, or it's because we have square roots. So we are going to do the same thing as when we distribute. Root 15 times root 5 is root 75. Root 15 times root 3 is root 45. And then you end up with root 75 and root 45 added together. Now we're going to do the same thing as we did up in number 1. 25 goes into 75 3 times. And 9 is the perfect square that goes into 45. And it goes in 5 times. So 25 root 3, they're factors of 75. 9 and 5 are factors of 45. The square root of 25 is 5. So 5 root 3 plus 3 root 5. And can we combine those at all? No, we can't. The only way you can add them together is if you have the same number under the square root. And in this case, we don't. Okay, moving on to number 4. Now these, they're being multiplied. So it's a little different. If they were adding, you couldn't add them together because it's not the same. But for here, you can multiply 20 and 5 because multiplying has different rules than adding. So 20 times 5 is 100. And this 2 doesn't get touched at all. You can't multiply the 2 because, well, it's not under the square root. You can only multiply what's under the square root. Well, the square root of 100 is just 10, so 2 times 10 is 20, and that's how you end up getting 20 for number 4. Number 5. It's 7 root 125, and 7 is going to stay out here, and we're kind of going to act like it doesn't exist until we get this one simplified. So we need to find the largest perfect square that goes into 145, which is 25, or into 125, which is 25. I don't know what I said. But 25 times 5 would equal 125. So really we're just splitting that square root apart. And then this 5 can't change, but the perfect square, 25 is a perfect square, so it simplifies to 5. So now 7 has not changed at all. But now we can multiply the 7 and the 5 because they match. They're both outside the square root. This 5 cannot be touched still. So we end up with 35 square root 5 as our final answer. Looking at number 6 now. What I'm going to do is I'm going to pull these apart. So I'm going to put 24 in its own square root, and then I'm going to look at this times, and so I'm going to look at them as separate things. Let's start by just looking at the square root of 24. Square root of 24 can split into 4 and 6, and then the square root of 4 is 2, so it can end up being 2 root 6. Alright? But this r cubed is a little different. Since it is an odd number, you can't just take the square root. What you have to do is make this an even number. Alright, well, how do I do that? Well, if you take, so r cubed means it's r times r times r. You take one of those r's away, see what that looks like, and you end up with r squared times r. So they're all still there. There's one here and there's 2 there, but you just pulled them apart. So it's no different than what we did from this step to this step. But now we have r squared. When you take the square root of a number squared, they end up canceling out. So it ends up being just r. Okay? Because basically what happens is when you're taking the square root of an exponent, you divide that exponent into. So like if this was r to the 4th, the square root of that would be r squared, or r to the 2nd. But since this is r squared, 2 divided by 2 is 1, so you're left over with 1 outside of the square root. And then this square root of r can't be touched, so it just stays under the square root. Alright, now we are ready to put everything together. We have 2 root 6, we have r, and we have a square root of r. So 1r goes under the square root, 1r stays out of the square root, and the 2 root 6 still stays in their place. So it's a little bit complicated, but if you go back through and watch the steps when you get to the practice, it'll be helpful. Right, moving right along to the next page. Here we have geometric mean. Is what this is called. So it's the positive square root of the product of the extremes. And you're like, wow, that's a lot of vocabulary words and a lot of weirdness that I haven't seen before. But I'll tell you, it's very similar. It's basically similarity is really all it is, but it's using shapes in a different way than you saw similarity at the beginning. So I'm going to show it to you this way. I'm also going to show it to you as similarity and show you how that works. And you can kind of decide how you want to use it. Basically, you've got this altitude right here in the triangle, and that's going to be your mean. And then you've got these 2 parts of the hypotenuse of the big triangle. Those are going to be your extremes. So you're just going to take those numbers, and the altitude will be your x's. It goes here and here. And then your extremes, these 2 numbers, will go here and here. And then you have your proportion, and you cross multiply and ultimately solve for x. Another way to think of it is as similarity of saying, all right, I've got the short leg over the long leg of 2 different triangles. L-O-N-G, not L-O-G, L-O-N-G. So my short leg for this triangle over here is A. My long leg for this triangle is x, so it's A over x. And then I look at this triangle over here, my short leg is now x, so that's what goes on top. My long leg is B. So we're looking at these triangles like they are separate. And I think it's helpful to draw them in like a highlighter. And so we've got, this is our purple triangle, and that is our green triangle. And it's the short leg over the long leg. Okay, let's look at what we have down here and do the same thing. So I've got, I want to do short leg over long leg. So it's just like similarity. Just like if I had 2 similar triangles, I'm trying to solve for x. we've got to find the one that matches. So for my green triangle, my short leg is my 2, and my long leg is my x. For my purple triangle, my short leg is x, my long leg is 50. So here's green triangle. I meant to circle it, but it didn't work out that way. So I guess I'll just highlight it. And then there is my purple triangle. So when we cross multiply, we are going to get 2 times 50 and x times x. So 100 equals x squared. Take the square root of both sides, and you get 10. Alright, so that's how these work. So I want you to try this one on your own. We've got short leg over long leg, so 8 over x equals short leg over long leg, x over 10. Okay? Cross multiply. We've got x squared equals 80. Ooh, that can't be simplified. We've got to simplify that radical. So 16 goes into 80 5 times. So 16 times 5. And then the square root of 16 is 4. So you end up with 4 root 5, and that is what x equals. Okay? Moving right along. Same idea here. We have our 2 triangles. Our green. And we have our purple. So we're going to do short leg over long leg, so 8 over 6 first. And then for our purple triangle, 6 over x, short leg over long leg. 8 over 6, 6 over x. Now we can cross multiply, and we won't have any square roots here, because when we multiply, we've got 8 and 6, or 8 and x, and 6 and 6, which is 36. And so we've got, it can look either as a decimal, or we can have 36 over 8, which will simplify to 9 halves. Okay, that could also be your answer, depending on if it wants it in fractions or in, confusing, or in decimal. Okay. The last one for this page, and then we only have one more page left. We have x over 5. Okay, that's my short leg over my long leg. It's equal to 5 over 12. So for this triangle, it's 5 over 12, short leg over long leg. When we cross multiply, we're going to get 5 times 5 is 25, x times 12 is 12x. When we divide, we get 25 over 12, or 2.08. And that is the geometric mean. So that is, we're using geometric mean to solve for different parts of triangles. Right, last page. So for this page, you can kind of use whatever is helpful for you. When it says H, it means hypotenuse. When it says SL, it means short leg. LL, it means long leg. When we're setting up our similarity, it has to be, like the same on each side. So if it's short leg over long leg, it has to be short leg over long leg on the other side. If it's hypotenuse over short leg, it has to be hypotenuse over short leg for the other triangle. So we're going to do the same thing here. Actually, I want to, we are going to use this color. So that one's orange. This big one is going to be purple. and this one's going to be green. So like when it's talking about short leg over long leg, WZ is the short leg for the orange triangle. And the long leg for the orange triangle is XZ. So that's like where they're getting these letters. And then WX is the whole triangle, short leg for the whole triangle, and XY is the long leg for the whole triangle. Then, yeah, so let's look at our, let me cover these up. So you want to take your highlighter and highlight these two triangles and then the big triangle. So I'm going to be talking about them as orange, green, and purple. So you have to solve for y first. What does that look like? How does one solve for y? Well, if you look, how am I going to do this? You have you want to solve for y, and this looks just like the one from the problem before. So all you are doing is taking your purple triangle and doing short leg over long leg, so 6 over 8, and then your green triangle, short leg over long leg, and doing 8 over y. It's pretty much exactly what we just did. The only change is when we solve for x and z. Y is the same. So if I cross multiply, I get 6 times y equals 64. And then when I divide by 6 on both sides, I get 32 over 3. All right. Cool. Okay, so since we've solved for y, we can now put that y is 32 over 3. But if you notice, when we do short leg over hypotenuse, so we are trying to solve for x, which this already has it solved for it, but I'm going to show you how to solve. Why are we doing short leg over hypotenuse? Well, we can't do short leg over long leg because we don't know what the long leg is. So we are going to do the short leg of this purple triangle over the hypotenuse of the purple triangle. But then we look and we're like, okay, orange triangle, green triangle. For the orange triangle, we have the short leg, and we are looking for the hypotenuse. Okay, well, that's great. So we will have an x, and we'll have an x, and it could be geometric mean. But we don't know how long the hypotenuse of the purple triangle is. So we have to add 6 plus 32 over 3 to ultimately find that number. And I don't know if you guys remember how to add fractions, but we need a common denominator. So 3 is going to be our common denominator, so we need to multiply this by 3 over 3. So I'm going to change this to 18, 3 times 6 over 3. And this is 32 over 3 still. So when we add these together, 18 plus 32 is 50. The 3 does not change. Remember, that does not become a 6. It is the denominator. So that is where this 50 over 3 comes from. So 50 over 3. So we want the short leg over the hypotenuse for both the orange triangle and for the purple triangle. Okay. Let's look at it. So our orange triangle would be 6 over x, short leg over hypotenuse. Our purple triangle would be x over the hypotenuse, which is 50 over 3. And then when we multiply these two, 50 times 6 is 300 over 3. And then x times x is x squared. So 300 divided by 3 is 100. Take the square root of both sides. and you get 10. So that's where that 10 came from x. Ooh, you guys cannot see that. Sorry about that. Well, now you can see it. Let's solve for z now. So if we are looking for z, we can do short leg over long leg of purple, and then we have to find another triangle that has short leg and long leg, because it's similarity, all right? So we need to do the short leg over the long leg for that. The orange triangle has that. We have 6 over 8. So we can, well, this one I actually did long leg over short leg. It really doesn't matter. You can do whatever you want. You can do short leg over long leg, or you can do long leg over short leg, because those are the ones you have. You'll end up with the same thing. So for my purple triangle, it is, my short leg is, or my long leg is z over my short leg, which is 10. For my orange triangle, long leg is 8, short leg is 6. So just make sure that both of the long legs are on, the same. For this one example, I have them on the top. My short legs, I've got them both on the bottom. We want to cross multiply, so 6z equals 8 times 10, which is 80. And then we divide by 6 on both sides. 80 divided by 6. We can divide both of those by 2. We end up with 40 over 3. And that'll be our final answer. So fractions are not the prettiest things in the world, but that is the correct answer. And that is all for Unit 7.1 notes.